Okay, section 1.6, we're going to be talking about geometric sequences. We're going to learn to recognize a geometric sequence. We're going to find a common ratio. We're going to look a little bit at graphing these, although we've done that in the past. And then we're going to write a geometric sequence recursively and explicitly and find partial sums of geometric sequences. So a geometric sequence, first of all, is different from an arithmetic sequence in that it's going to involve multiplication between the terms rather than the addition subtraction that you have with the arithmetic sequence. So a geometric sequence is going to be a sequence in which the terms are found by multiplying a preceding term by a non-zero constant. The quotient of the consecutive terms in a geometric sequence is called the constant r. And so instead of d, like we had with the arithmetic sequence, we're going to have the constant r, which is our common ratio, is what it's referred to as. So you're going to see us talking about r, which is a common ratio, a lot with the geometric sequence. So the recursive form for a geometric sequence is here. So that's here, and let's just talk about it a little bit. So you've got the nth term is going to be found by taking that common ratio and multiplying it by the previous term. Okay, so for example, let's say that we have 2, 6, 18, and then 54. Okay, it's a sequence that continues. If we just take the 6 here, we know 6 can be rewritten as 3 times 2. Now let's think about where we get that. What our common ratio here is that we are multiplying by 3 every time. So that 3, that's our r, and that's going here. And then the previous term, just like we did, just like we've done before, the previous term is 2. So that's an example that we have our nth term is equal to common ratio times the previous term, which in this case was 2. Okay, so then there's also the explicit formula for a geometric sequence, and this is found. This is our explicit formula. So again, it's going to be the nth term is found by using the first term this time. So the first term in the sequence times the common ratio raised to the n minus 1 power. And if we look back at the previous example and compare it to that, we knew in the previous example that the third term was 18. So let's just try out this formula. We could say that the nth term is equal to 2 times 3 raised to the n minus 1. And then the third term would be, the third term would be 2 times our common ratio, which is 3, raised to the 3 minus 1, which is going to give me 2. And that does turn out to give me 18. So it checks out. Okay, so the explicit form, that's an example of the explicit form working the problem. Okay, here we have an example. Got a little off track here, so this should be like this. Okay, and what we're looking to do is find out whether or not it's a geometric sequence, and if it is, we're looking for the common ratio, and then we're going to write a recursive function for this. So in this case, from 5 to 10 and 10 to 20, 20 to 40, we quickly realize that we are multiplying by 2, multiplying the previous term by 2. So yes, it is a geometric sequence. The common ratio r is equal to 2, and then when we go to write our recursive formula, it's going to be that the nth term is equal to the common ratio times the previous term. And there we have that one. Let's try the next one. Okay, so this one you might not see quickly, or you may or may not see quickly. You are multiplying by a third each time. Okay, so again, yes, this is going to be a geometric sequence with common ratio of 1/3. And to find the nth term of the sequence, we take our common ratio, which is 1/3, and multiply it by the previous term. And there we have our recursive formula for that example. Okay, so for this example, we're going to end up needing a calculator. So let me pull that up real quick. And so what we're doing here is finding the common ratio of the geometric sequence with the first term being 3, the second term being 6. And then we're going to list the first 5 terms of the sequence. And then we want to graph this. Function. So you need to start out, there are a couple things you need to find if you're going to find the recursive formula here. First of all, you need to know what the first term is. Let's minimize that. Okay, so we need to know what the first term is, and we have that already, so that's good. And then let's write that down. The other thing we need to have is our common ratio. Now, to find the common ratio, in this case, since we have the second term and the first term and they're consecutive terms, then all we have to do is take the second term, or it may not be the second term, it's the next term, okay, and then divide by the previous term. So this time I'm taking the second term and dividing by the first term. It could be the fourth term divided by the third term, or any sort of consecutive terms where the larger one is the numerator. So in this case, we know our second term is 6, our first term is 3, and that's going to give us 2. So we know R and we know U. And then we could go through and find our different terms, but it says that we need to give the recursive function here. So let's go ahead and write our recursive function in this case. So the nth term is going to be equal to the common ratio times the previous term. Okay, and then to find the terms, so the first term we already know is 3. The second term we already know is 6. The third term we know would be 12. The fourth term would be 24. And then the fifth term would be 48. Okay. We have that example. And now we're going to look at one where we are finding, this time, the explicit form. And so this one's a little bit more difficult because, actually no, not this one. This one is still pretty easy because we're given pretty good information with this one. So we're going to write the explicit form of a geometric sequence where the first two terms are 3 and -3/4. So key here, at first I was thinking it might be a little more complicated, but we noticed that the first two terms were given consecutive terms, so that makes things a little bit easier. And then we're going to find the first 5 terms of the sequence, and we're going to find the explicit formula this time. So remember, we're finding explicit. So to do that, we know first of all that our first term is 3. We need to go and find out what our common ratio is. So we're going to take the second term, which is -3/4, and divide it by the first term, which is 3. And when we simplify that, if you remember operations with fractions, you've got 3/4 times, so this is actually 3/1, so I can say times 1/3, and the 3's would cancel, and I get -1/4. Okay, so R is -1/4, and then now that I have that, I can go ahead and write my explicit formula, which is going to be that the nth term is equal to 3, which is my first term, times the common ratio raised to the n-1 power. Okay, and now that I have that formula, I can go through and find each term. And I can plug those into the formula here. So the first term we already know is 3. The second term is going to be the -3/4. The third term, if I'm using my formula, then I can use my formula if I'd like. So it's going to be 3 times -1/4 raised to the n minus 1, and in this case n is 3, so it's to the second power. That's going to simplify to give me 3 over 16. Okay, and then to find the fourth term, it's going to be 3, negative 1/4, raised to the third this time. That's going to simplify to give me negative 3 over 64. You should notice that you have alternating positive and negative signs here also. So then we have the fifth term is negative 3 times negative 1/4 raised to the fourth power, and that is going to give us 3 over 256. Okay, and so yeah, you just want to go back, make sure you don't have any mistakes. You've got positive, negative, positive, negative, positive, and that's happening because your common ratio is a negative value. Okay, so that's example 3, and we have a few more here. And then we're going to learn, or actually one more, and then we're going to learn about partial sums. So this time we're given the third and the sixth term. So this case is a little different, a little more complicated, because we don't have consecutive terms. We've got the third term, which is 80, and we've got the sixth term, which is negative 5,120. Okay, and so given that information, we need to find a couple of things. First of all, we need to find our common ratio, and then after we find our common ratio, we are going to need to find our initial value, or our first term here. Okay, so we're actually going to set up a ratio to find this, because there are things that we know about our third term and our sixth term. First of all, we know that they are 80 and negative 5,120, but we also know that we could write them in different forms. For example, this could be written as, from what I know about my explicit formula, it could be rewritten as the first term times the common ratio raised to the n minus 1, which would produce 2. And then this could be, the sixth term can be rewritten as, using the explicit formula, as the first term times the common ratio raised to the n minus 1, n being 6 this time, so here to the fifth power. Now, once I have that, I've got two different forms of the third one, and then I've got two different forms of my sixth term. So then that means I can write two equations here, or I could write a ratio, similar to what I've done in one of the other examples. So what I'm going to do is write a ratio of u to the sixth over u to the third. We know that the values of those are 80 and negative 5,120, so I can rewrite that as negative 5,120 over 80, and set that equal to this here, and the first term r to the second. Okay, and so then I just use these two right here, and I can then simplify. You notice pretty quickly that these two can cancel out, and you can also cancel out some of your r's, and we can simplify this guy. So when I do that, I end up with negative 64 is equal to r cubed. And that means that r is going to be negative 4. Okay, so I've used that information to find my r, and now that I have my r, okay, so first thing we did was to find r. Now, after I find r, I'm going to come over and find the first term, because we need the first term if we're going to write the explicit form of the sequence. So we're going to start out by using, I'm going to choose to use my third term, 80, rather than my sixth term, just because the third term is smaller. I know that the explicit formula for this would give me this. Okay, and I know that it is equal to 80. Okay, so using this this right here and what I know from R, then I can find what I'm looking for. So I'm looking for my first term. I know already from here that R is -4, so I'm going to plug -4 in. Squared is equal to 80. And then so I get, and that means that my first term is going to be 5. Okay, so I have those two now. And now that I have those two, then I can go ahead and write my explicit formula. And that is just going to be that the nth term is equal to 5, which is my first term coming from here. My common ratio raised to the n minus 1. And that's my explicit form for this geometric sequence. Okay, now we're going to go on and take a look at partial sums here. So we have partial sums similar to what we did with, I mean, it's a different formula, but it's partial sums similar with the geometric sequence. So if I have this, then I can, this is going to come in handy. Let's say I ask you to find the sum of the first 100 terms. Of course, we don't want to go and find the first 100 terms, so I'd use this formula as a shortcut. And let's just go ahead and try an example here. So in this case, we notice we're trying to find the partial sums of this. So the idea here, I mean, it tells us each of the terms. So first we got 2, 3, 8 terms. Now we could go through and add those up since they're given to us. But what we would like to do instead is actually come up with a fractional value. If you put these in your calculator right now, you'll realize that you can get a sum, but you're not going to be able to get a fraction. So by using the formula that we have, we're able to actually come up with an exact answer. And we're going to give that answer as a fraction. So first of all, let's go through. We're working with 8 terms here. And we know that we are going to need to find our common ratio. So to find our common ratio, it's going to be pretty easy this time because we've got consecutive terms. I'm just going to take my 1/4 and divide it by a previous term. You could choose any 2 values here. And you should notice that you're going to get a negative value because you notice your signs are alternating here. So just a quick review on fractions. You've got your 1/4 times a reciprocal, so that's a -4/3. And those are going to cancel, giving us -1/3 as my R value. So we're looking for a sum, so we're going to use our summation notation in this case. So we're looking for the sum from 1 all the way up to 8. And then what we're going to put in here is our explicit formula for this, okay? So we're starting out with a value of -3/4, and we're multiplying that times the common ratio, which is -1/3, and we're going to raise that to the n minus 1 power. Okay, and so we're looking for the first 8 terms of that, the sum of the first 8 terms. So when we go through, let's first of all look at the formula for this that we learned about on the previous slide. We're going to use this here. So we've got our first term, and then we've got 1 minus r raised to the k over 1 minus r. Okay, so that means now that I can come back using this and say that this sum is going to be equal to -3/4, because that is my first term. And then I've got my 1 minus r. I know that my common ratio is -1/3. And that -1/3 is going to be raised to the 8th power, because that's what my k is, over 1 minus -1/3. Okay, so from here it's just a lot of simplifying that we have to do. So once we have that, I'm going to take this to the next page because we've got just a little bit of work to do. If you plug this in your calculator right now, again, you're still going to, and you're sort of just going to want to go until you can get an exact answer. If you plug this in your calculator right now, you'll get an answer, but it's not going to convert to a fraction for you. So, and we'd like to have the exact answer. So I can copy this. Okay, so here we go. Here's what we're working with. Here's what we're trying to simplify. And maybe you have, I'll give you a second, maybe you have already tried to plug this in your calculator, maybe you haven't. But if you plug it in very quickly, you'll notice that you're not going to be able to get a fraction for it. So let's just go through and use what we know to simplify this. So first of all, I'm going to keep my negative 3/4 for now, and I'm going to work with that exponent up there. So I've got 1 minus negative 1 to the 8th power is just going to give me a positive 1. And then we've got 3 to the 8th in the denominator over 1 minus 1/3 is going to be 1 plus 1/3, which is going to give me 4/3. Okay. So now that I have that, I'm going to take this fraction 4/3 out, bring it out front. So I've got my negative 3/4 to start with, times I'm going to bring that 4/3 out of the denominator. So multiply by the reciprocal, it's going to become 3 over 4 here. And then I'm left with my 1 minus 1 over 3 to the 8th. So again, you can try plugging it in your calculator at this step, but you'll notice that you can't get a fraction. We want exact values, so we need to keep going, simplifying this. That's going to give me negative 9 over 16 plus, let's see, no, it's not going to give me a plus, I'm sorry. Negative 9 over 16 times 1 minus 1 over 3 to the 8th. So again, simplified a little bit, but not quite enough to help me out yet. So now I'm going to take that, distribute it here and here. And the thing you should notice that's going to help us at this point is that 9 is 3 squared, so we're going to have some numbers that cancel out. So I get negative 9 over 16 plus 9 over 3 to the 8th. Okay, now 3 to the 8th, let's make sure that's clear. That's 3 to the 8th. But 9, another form of 9, is 3 to the 2nd. Okay, so if that's 3 to the 2nd over 3 to the 8th, then we can cancel out 2 of those, leaving a 1 in the numerator. And 3 to the 6th in the denominator. Now at this point, you can probably go ahead and plug this into your calculator, or we might need to get a common denominator. Either way, you can work, try to see. If you need to get a common denominator, you just need to multiply this one by 16 over 16, and then you would have to multiply this guy here by 3 to the 6 over 3 to the 6. So I think you can probably plug it in your calculator at this point and get it to give you the fractional value of negative 410 over 729. And there we have the exact value, which is what we're looking for. And that's all I have for section 1.6. If you have any questions, bring them in to class tomorrow.